Welcome to the Stray Pointers podcast, where seemingly ordinary people join us for extraordinary discussions. You're listening to Season 2, Episode 6 of the Stray Pointers podcast. This episode was recorded on February 20th, 2024. I'm your host, Jim Lawless. Please visit straypointers.com for more information about the show, including the show notes for this episode. Tonight, I'd like to welcome hacker, problem solver, polymathematician, artist, and engineer Thomas Cherryhomes. Tom, welcome to the show.
Thank you very much. Glad to be here.
Tom, I've heard about some of your exploits on the Antic Atari 8-bit podcast with Kay, Randy, and Brad, and I heard about FujiNet. So I thought I would see if we could get together and talk a little bit about that. But I wanted to start by finding out a little bit about your earliest interests in tech. You've obviously got some interest in electronics and programming. So where did this all start?
Well, I had a very unusual childhood. I was born 6 weeks premature on October 24th, 1978. But because of complications at birth, because of the cerebral palsy, I could not walk until I was almost 5 years old.
Wow. Okay.
And so I think what wound up happening was the energy that was normally used to take and move myself around went to my head.
Okay.
And so during those early years, what ultimately happened was Dad had already gotten computers in the house. TRS-80 Model 1, a PDP-1145 in the basement, an MSI 8080, and these things were already just were already in the house and just part of daily life there. And so I became curious about them, and Dad would sit me down in front of them, and even though I couldn't walk very well, I learned to type very early. By 2 years old, I was already typing proficiently on the keyboard, even though I couldn't walk. And so ultimately, what wound up happening was I would watch Dad enter programs and things in BASIC on one of the machines, either the Atari or the Model 1 or the PDP-11, and would ask, it kind of became this curiosity of wanting to know what was happening. And so I started writing code by the time I was 3.5, I was writing code in BASIC. By the time I was 5, I was writing code in 6502 assembler for the Atari 800 machines. And it just kind of mushroomed from there. And because Dad had an interest in all of these machines, and because we had the money to get them, they would show up at our place, and I would learn every single thing I could about them, all the way down to the hardware registers.
Was he a programmer by trade?
He was kind of a Swiss Army knife. He was a programmer when he had to be. He was a decent hardware technician, and he knew quite a bit about engineering. So he would contract and do things from time to time, and it was something that was pretty consistent around our house. And while that was happening, Mom was an artist, so I got both sides of that at the same time. And the way it really worked around our house was Dad was always of the opinion that if he knew something, his first inclination was to take and share it with everybody else. And Mom was the same way. So what wound up happening, especially as we got older and into adolescence, people would all of our friends, my brother and I have a brother, and his friends and my friends would come over to the house, and we would all just be doing stuff together. Dad would be showing how to build computers, or we would be playing Doom, or I would be, of course, I had my own interest. I was coding, but I was also doing music. I was painting, doing all of these different art type things as well. So that was just kind of my childhood. So uh, when I ultimately went off to school, I made the fundamental decision that since I had already been steeped in computers and computer science, that I didn't need to go to school for computer science. And so, therefore, I went off in a very opposite direction and went to the Art Institute of Dallas to get a degree in visual communications and multimedia design, because that was one area that I did not have, I wasn't being directly absorbed to. And it worked out pretty well because it rounded me out pretty well, I think.
Okay, then what can I ask what professions then followed art school?
God, everything. And I spent, I got my first programming job, literally paycheck, when I was 8 years old, and had been receiving paychecks abstracted through my father's company, kind of under the table, until I was old enough to legally be employed, and um, then from that point, I had also taken an interest uh, in music and in audio, which was something that other members of my family were into. My One of my uncles was an audio engineer. Uh, Another one of my uncles was a concert organist, big pipe organs and the like, and all of that just kind of filtered through too. So I spent part of my teens uh, training to be also a studio musician and a session musician along with all of that. That part ultimately didn't work out for a couple of reasons. The biggest was that by the time I got old enough and the early 2000s rolled around, the need for professional session musicians and all of these people who knew how to program synthesizers, who knew how to do all of these different things, make sounds and the like, weren't needed as much when the producer could just dial up whatever he wanted on his laptop.
Sure, sure.
So, yeah.
So what has been your longest running profession then?
My longest running profession has been for the last for the last 12 years, I've been doing DevOps, and basically for a number of different companies. Essentially, I fell into it by I fell into it kind of by accident because there weren't really. I had become interested in uh, through previous work in high performance computing. I got used to and understanding how to build things like Beowulf clusters and how to use them, how to write code that managed to cross to them. Um, that didn't turn out to be as big of a job get as I had at least intended. And so ultimately, what that meant was, well, okay, there aren't many jobs doing all of this. Why don't you transition over into this new field with this new thing called OpenStack and start basically doing build automation and whatnot. And that's kind of where I've been ever since. For the last since the end of 2015, I've been employed by Ericsson Global, doing DevOps R&D, essentially being one of their R&D centers to take and do large scale build automation for a wide variety of internal and external clients.
Okay, so you're well versed in contemporary technology, but you have a lasting interest in retro computing
I never
technology.
stopped. That's the
Okay.
funny thing. The way my head works, um, I work in several time frames at once. I never stopped doing the retro computing stuff at all. So it was something that I enjoyed because I loved how the machines were put together, and I could understand every single aspect of them, and I could control them and do neat things with them. So it made sense to continue doing that even when the machines got much more complicated. But that doesn't pay the bills, and I
Sure.
wouldn't want it to pay the bills for way too many reasons. So I do the new stuff now, and and just basically to pay the bills, to make sure that my wife and my daughter are insured and taken care of, and I don't worry so much about trying to push the envelope in my day job. I'm more interested in trying to make something good to bring joy into people's lives through the work that I do in the retro computing community.
Okay. So let's talk about FujiNet.
Hmm.
If you had to describe it to someone familiar with, old computers, 1980s era computers, how would you describe FujiNet?
Imagine, quite literally, taking your Atari 8-bit or Commodore 64 or Apple II or Coleco Atom and hooking it up to a huge amount of software that's available on the internet that you don't have to have locally. You can connect to it and you can load it directly to your machine. That's the virtual disk aspect of FujiNet.
Okay.
Furthermore, what if you could take and use a copy of Print Shop and print out to a PDF that you could print to a modern printer? That's the virtual printer aspect. What if you could take and connect to an array of bulletin board systems like we used to way back when? That's possible with the virtual modem. But there is also a virtual network adapter. And this network adapter does tons and tons of protocol offloading. That is, it can connect to a variety of contemporary protocols, everything from TCP to HTTPS. It can handle all of the crypto, SSL, TLS, but it can also take and parse JSON and XML documents on the device itself. It can do this because it's got a microcontroller that's hundreds of times faster than the computer it's connected to. But because of that, we can basically take in our firmware that runs on that device, have it do all the heavy lifting, and make it so that it exposes a nice, clean I/O channel to the target computer. So this means that not only can you do all of the other stuff that I've described earlier, but you can write new network applications in BASIC. You want to write something, you want to write a Mastodon client? No problem. You want to take and write a Google Drive client? No problem. It can talk to all of these things. And it does all of these things in a very inexpensive device that the average price is around $80 now. That's the pitch.
There had been modem emulators that could
Mm-hmm.
get these old computers onto the internet. Excuse me, it was just basically a telnet style interface so they could do
Mm-hmm.
point to point connections elsewhere. Where did you get the idea to push it that much further that this became sort of an internet enabling appliance for these old computers?
Well, in order to answer that question, I'm going to have to take and split it into two pieces.
Okay.
The first is I came to a device that my now co-founder of FujiNet, Moswald, had been building on his own since the summer of 2017, 2018, using an older version of the microcontroller that we use now. And it was just a modem, but he had done the forward thinking step of taking all of the IO pins on that ESP8266 chip that he had put on the board and connecting all of those pins out to the Atari SIO peripheral connector. And because of that, sorry, and I'll back up a bit, just a tiny bit. While he was doing that, I had been working on another project bringing a version of Plato which is a programmed learning and teaching operation. That's what the acronym stands for. And it's an ancient online system that was designed for educational purposes. That is one hell of a rabbit hole if you ever want to go back into it, because it digs all the way back into the early 1960s. And it ran pretty much continuously all the way until 2015 when NovaNet was shut down. But that's a whole different story. I had been, through the efforts of the current rights holders of Plato, they had given permission to a group of enthusiasts to allow for a whole version of that entire system. Now, mind you, this was a system that ran on very large controlled data supercomputers, 60-bit machines with 8 megawords of memory, just absolute beasts of machines for 1979, 1980. Uh, had basically imaged that whole system that control data would sell to institutions and the like, FAA, and so on. In fact, that's where the version of ours that we use right now actually came from. It came from a disk dump from the FAA. But Federal Aviation Administration, for those that aren't in America. So they had taken and made it so that we could pair it with a supercomputer emulator that it needed to run. It was called DT Cyber. And so that you could run it, and so that you could expose its network connections out to the rest of the world and people could connect to it.
So this is emulating a control data mainframe?
Yes, super
Okay.
mainframe. Yes.
Okay.
Really have to point out how big this goofy thing is. I mean, it's has 24 individual, it has 22 peripheral processors up to 2 central processors, can address an unbelievable amount of memory for the time, and the word size is absolutely nuts. The only other thing I will also mention is that the ALU on this guy is rather, on these particular family of machines, is rather unique in that it uses ones complement arithmetic. So therefore, you can have the concept of zero, the number zero, and the number negative zero.
Okay.
So funny thing that
You revived Plato?
I actually I helped take what these enthusiasts had built together
Hmm.
and worked on it on my own to take and build a version of it that could really work well for retro computing enthusiasts. Because at one point, Control Data had actually taken and released what they called Micronet, which was a way to dial into these systems from Atari 800 computers, Apple II computers, and the like.
Okay.
And I was trying to bring some of that back to those machines. And to that end, I wrote a Plato terminal emulator. It was written in very plain, very portable C language. And because of that, I was able to port it to more than 40 different systems in the span of about 2 years.
That's quite an accomplishment.
Thank you. I was able to do it precisely because of my previous experience knowing and figuring out all of these different platforms.
Yeah, I can't imagine staying with a project for half that length of time, let alone going through 2 years to get to the goal.
Well,
That's amazing.
I wanted to see these bring ups happen for all these different machines. And I love writing code for all these different machines. So I wanted to see this happen. As part of that whole process, um, it became clear that the connectivity options on the Atari 8-bit computers weren't all that great. Your primary option was to take an Atari 850 expansion interface. This was a peripheral box that you bought separate from your machine that gave your Atari 800 4 serial ports, actually 3 serial ports and a 20 milliamp current loop port for teletype use, funny enough, and a, um, and a parallel port, Centronics compatible parallel port. This device, because of the way it had to be built at that time in 1979, had a number of flaws. And the thing is that you have to have this box, then you have to have a Wi-Fi modem, for example, one of these Wi-Fi modems that you've mentioned before, connected up to the RS-232 port, connected into one of these RS-232 ports on the 850, then that 850 connected into your computer. And I really didn't like that solution at all. It was way too awkward. And uh, even before the modem emulators were available, people were using old Lantronix MDS-10, MDS-100 type, MSS-100 type network to serial bridges to do the same thing. And those things are extremely flexible, but they are extremely difficult to set up. So we sat down so Moswald and I sat down and said, okay, how could we do this better? Well, we could actually take and make it so that all you have to do is plug the modem directly up to the computer and you're done. And that's how we started. FujiNet was started primarily as a modem. But knowing me, I'm sitting here thinking one day, and I'm going, gosh, that ESP8266 isn't doing much most of the time. And I asked Moswald the question. I said, are we hooked up to the command pin? Now, the command pin is one of the pins on the Atari SIO connector. It signals to it signals to the peripheral. The Atari asserts this signal to the peripheral to indicate that it is sending a command down this command bus. And this is important because this particular bus is a serial bus in which you daisy chain all your peripherals, your disk drives, your printers, your 850 serial interfaces, and they all get snaked along in various bits of cable, but they're all running along the same set of wires. So they needed a way to take and signal. And of course, Moswald said, yeah, it's connected. So I thought, wonder if we could make this thing act like a disk drive. Would there be enough time for it to act like a disk drive? Yeah, sure, no problem. Roughly about 2 weeks later, I got it booting a single a program that was exactly one disk sector long, 128 bytes. Okay, great. Huh. Okay, cool. Wonder if I can get this thing to boot Jumpman off the flash. Okay, do a little bit more work, get the timings down, spend a whole lot of time with the Altera hardware reference manual to make sure that we get the timings right and everything, and we managed to get Jumpman booting. And I think, okay. In the meantime, I had contributed some time in 2019 as part of the Plato project, which was called Errata Online, by the way. Um, I had done a version of Plato Term for the ZX Spectrum and its SpectraNet interface. And as the SpectraNet was an Ethernet interface that plugged into the back of the ZX Spectrum and gave you some wonderful internet connectivity. It had an Ethernet chip that could do protocol offloading for certain things. And so I spent some time with it and saw how it worked, and I really liked the way that it integrated into how the ZX Spectrum operated. And so one of the things that they had developed over on the SpectraNet side was a simple file sharing protocol that they had called TNFS, Trivial Network File System. And I thought, gosh, I bet I could take and make that work really well inside this 8266. So I hacked up an implementation that would take and you could point it in the direction of a file sitting somewhere on a file server, on the network somewhere, on the internet somewhere. And we got that working. And as luck would have it, we zoomed forward a few more weeks where we started hacking on this modem in July of 2019. Fast forward to sometime just almost in August at this point, that Um, we we get it working, and I'm thinking, okay, let me go spin up a cloud instance over on DigitalOcean. I'll run a copy of the TNFS server over there on cloud on DigitalOcean. I'll put a copy of Jumpman over there. I'll have it mount, and let's see if we can finally get this thing to boot. So we get all of that set up, and as luck would have it, right as I'm about to start the test and to do the test in earnest, one of the connector pins on my development board snapped off. Now, I have cerebral palsy. I do not use a soldering iron. Please do not let me use a soldering iron. I will burn the house down. So uh, it had come loose, and as luck would have it, it wasn't the ground pin. It was the data in pin, the one pin I needed for this to work. So I immediately take and message Moswald and plead with him to please, dear God, take the latest bit of code that we have and try this. And sure enough, about 30 minutes later, he shoots back a video booting Jumpman from his house to the DigitalOcean server, which is about 2,400 miles away. So using the longest, you could visualize it as the longest peripheral cable attached to an Atari ever. And it worked. And it was absolutely amazing. So it mushroomed from that point. And over the course of that initial development, which started in August of 2019, until almost December of 2019, almost to January, we did approximately 43 individual test programs in Arduino, each exercising the bits and pieces of functionality that we wanted to see inside this device, isolated by themselves, to see how it actually would work in practice. And right there at the end of December, um, another one of my friends that I had known for quite some time, he had done some hacking with me on Plato Term, making a cartridge version of the ESP8266 to go on the Atari and a few other things that we had experimented with. Joined the project in earnest because he wanted to add virtual printer. And the way that we added virtual printer was very different. We kind of deliberated on this, and we chose what we considered to be the most difficult but the most compatible option that we could think of, which was to write our own PDF parser from PDF renderer from scratch, and to painstakingly emulate each set of printers that we wanted to use, along with creating their fonts. And as a part of that whole process, Jeff actually built the printer emulation off in isolation by itself, but he used, instead of Arduino, to his credit, this is a big reason why this happened, he pulled down a copy of Platform.io, which is a very popular development platform for Internet of Things and embedded system development. Very, very professional. And he started building the printer emulation in that. And as part of that process, bringing over the test programs that we had written in Arduino and building a backbone so that all of these devices and things that we had developed in isolation could run and work at the same time, the very first iterations of our service loop. And it kind of went from there. The final major change that happened occurred during the spring of 2020, when another contributor, Oscar Fowler, took realized, we had all realized by this point, that we had shifted over from the 8266 over to the ESP32, and that in order to really utilize every aspect of that ESP32, we needed to use the vendor framework that Espressif provides for professional use. That's the ESP IDF. and that we needed to port all of our code that we had done up to that point, move it over from Arduino to ESP-IDF. He did that in the space of 2 weeks, and it worked. There were, I think, maybe 2 bugs that had been that moved over as a result, but it worked. And so uh, that was our ability from that. And because we did all of that movement from Arduino, from ESP3266 on Arduino to ESP32 running ESP-IDF and using Platform IO with all of its industrial strength frameworks, we were able to take and slice things up into nice and neat component boundaries for the most part. We're still cleaning some things up, but for the most part. And we could then take and start looking at it was at the insistence of one of my other longtime friends, uh, Atari alumnus, Joe DeCure, who was one of the system designers for the Atari 800, one of the system designers for the Atari 2600, one of the primary standards bearers for USB, one of the primary standards bearers for Bluetooth low energy, and so on, and so on, and so on, who basically said, you guys should really start thinking about moving this onto other platforms. Okay, sure. And so we started factoring things out, and we got more people in on the project who ultimately helped with slicing things up and breaking things out so that we could take and add new buses, which are the connections to each target machine, the device framework so that we can add the individual sub-devices, the disk drives, the modem emulators, the network cards, etc., and the media types, which are all the different disk formats and disk image formats that each of
Wow.
these systems need to be able to handle, and to put them in a way that can be managed and can be built based on if I need to take and build a FujiNet for the Coleco Atom, then it knows which pieces to build. Or if I need to build one for the Atari 8-bit, it knows which pieces to build, and so on.
So how many systems do you support now?
A lot. Well, we're a pro. That's the thing. I consider right now the Atari 8-bit, the Coleco Atom, the Apple II, and the Apple II, the Atari Lynx, uh, and I'm probably missing one or two as working extremely well. And there are a number of other machines, more than a dozen or so at this point, that are in various stages of bring up, such as the Commodore serial implementation. The Commodore version works with the all every Commodore with an IEC port. So that's Commodore 64, 128, plus 4, VIC 20, so on. Um, we have another enthusiast who started work on FujiNet for the RC 2014. It talks over SPI, serial parallel interface, synchronous parallel interface. Or yeah, anyway. We have a bring up happening for the ZX Spectrum, and that's being done as an exercise using entirely nothing but TTL logic. The idea there is to see if we can implement a generic bus interface using nothing but the standard TTL logic that can be vectored off onto other machines. But we also have this very same Jeff Pietmeyer who helped with the virtual printing, also spearheaded the Apple II bring up that we currently have that's working well. And he moved over to the Mac 68000s. This is important because you really can't fit Mac TCP onto a Mac 128K. You just can't. There's no memory for it. So this kind of gives those machines an opportunity to talk. And basically, I think maybe out of sheer challenge, we decided to use the Mac floppy port, which while it also uses an integrated WAS machine like the smart port on the Apple IIc that the Apple II version uses, it uses it differently. It uses it faster. So we had to add an RP2040. The RP2040, or the Raspberry Pico, as some people know it as,
Okay.
is a wonderful chip because it has, as part of its design, a programmable I/O macro block, a series of circuits that implements a very minimal computer that can move things in and out of I/O space that's accessible by the primary processor that's on the Pico. And it can do those things very fast, and it can do them under DMA. So that means that it can do things like simulate a ROM or simulate an 8-bit bus interface and act as a bus front end without exerting very much pressure on either the ARM or the ESP32. Because the ESP32 is a wonderful microcontroller with tons and tons of dense I/O, but you can't move the GPIOs that fast. There's too much. There's too much in the way. Too many tasks going on in the operating system. Too many things just happening. So we had to split all of that out. But because of his work there with the Macintosh, we also have not just the one way with generic TTL logic, but using an RP2040 to serve the same function to talk to these large parallel buses. And that brings up a very important point. Um, each machine that we do a bring up on gives us a vector to 10 more. The lessons that we learn from each bring up can be brought forward. So while it doesn't make it necessarily faster, it makes these other bring ups possible. And that's how we're systematically doing it. And so you have people that come into our Discord and want to bring up for a particular platform or whatnot. And for those people, my primary function or the core development team's function is to point out sections of the code where things are, how things map out, and try to get these new people that have this anxious energy that want to see this thing brought up on a target platform, give them everything that they need so that we can keep the enthusiasm going for them to be able to do the bring ups. And it's worked out pretty well. So I think we went on a rather long trail there, but
I think you answered my question. I know that you mentioned Joe DeCoeur. Am I pronouncing
Mhm.
his name? You
Yeah,
mentioned I had seen that you had uh, done a presentation with him at the Vintage Computer Fair, Southern California, just over the
yeah,
weekend here. Do you tell us a little about the con and your presentation?
absolutely. So VCF SoCal happened over this last weekend. VCF SoCal is one of the many shows that fall under the umbrella of the Vintage Computer Federation, which are a loose group of different individuals, all in different parts of the country that share a common interest in preserving the legacy of vintage and retro computers. And to that end, a number of different shows are put on throughout the year. The first Vintage Computer Festival actually happened was VCF West, and that happened in the Mountain View area. And so California is a big state, so they decided over November of 2023 to set one up in Orange County, and that was the one I went to this last weekend. There are others, such as VCF East in New Jersey, VCF Pacific Northwest up in the Seattle area, and so on and so on and so on. And with each of these shows, you have a place where it's kind of split into two main things. You've got a giant banquet hall type setting where you can have people setting up different exhibits and or vending areas. It can be one or the other typically, to where they will say, oh, this is I spent the last 10 years restoring this PDP 1145. Here, this is it working in action. Or this is our new product right here, and we have a few here for sale right here at the booth, that sort of thing. And to that end, we actually had a FujiNet demonstration in that hall with a Coleco Atom, an Atari 8-bit, and an Apple II, and a Commodore 64 with monitors and everything, and FujiNets all connected up to the internet, all doing different things. So that's the first part of it. And the second part of it is typically lectures and talks from various different people in the lecture hall. And that was the context for Joe and I, where there was the idea by the showrunners who basically said, okay, Joe DeCure made the Atari, was one of the system designers in the Atari 800. And they thought, wouldn't it be interesting if there was a connection made between the decisions that had been made 40 years ago and how those decisions allowed FujiNet to come into existence. And that was basically the nature of the talk. It bounced back and forth between Joe and I, to where uh, Joe would relate the historical context of the Atari operating system and its I/O system design, the I/O control blocks, the digital device control blocks, the decisions that led to using the serial interface, and how all of that kind of panned out, and how it was all implemented in the ROM. And then it would hand off to me, and I would take and provide the context of how FujiNet would use those things, like how they happen to leave not one but two interrupt pins on the SIO connector, which allowed us to basically not have to poll the FujiNet all the time for network traffic. The FujiNet can take and wiggle the interrupt line and say, hey, I've got traffic, and the Atari can go, oh, okay, and then respond to it. They put all of that plumbing in, but there wasn't really a device to use it, but it was there for us to use. So we took advantage of it. And lots of things like that. They put in the ability not only for that, but also to uh, create a serial clock not only inside the machine, but to synchronize to a serial clock outside the machine. So you can and so there was lots of very simple but very well thought out ideas that made it so that we could hook FujiNet up to an Atari 8-bit machine, and we could integrate it into the operating system as just another device alongside the keyboard, the disk drive, the screen editor, and so on. And applications could just use it and be none the wiser, because the operating system routines are just there. Would just load a handler for our device, and all of a sudden now you can you can edit a web page directly from Atari Writer directly to the web server without any intermediates in between. So, things like that.
So were these talks recorded? Are they
Yes,
gonna? Okay. So are they available yet?
they are not available yet, but I have a feeling that they will be soon. I asked Steve, who was one of the showrunners, and I'm waiting for a response back from him on that. But they did record it, and they did say that they would release it as soon as they could. I want to try to get a definite ETA on that.
Great. Well, Tom, anything that we haven't covered that you'd like to talk about?
I mean, really, the work that we're doing here with FujiNet, it it didn't start out like this, but because of the wonderful bits of serendipity that happened along the way, it became possible with all of the connectivity and integration that we found. We're now able to start thinking about things in broader, more abstract terms, and in a way that I really enjoy thinking about, which is social terms. Um, the retro computing communities have all been, for the last few decades very isolated by design. They go off in their own little corners and they do their own little things in their own little corners, and the other communities really don't know what any of the other communities are up to. And given that I love all of these machines, I love all these machines. I wanted to see, now that we have this device, now that we have this means of connecting these machines to do together to do useful things, what if we could get them to not only take and look over the fence and see what these other people are doing, but to also take and create a gravity well to pull these people out from the corners and put them in the middle so that we can try to take and do something fun and interesting and something I haven't even thought of. That would be great.
Yeah, that's
That's
that
really
great is an understatement.
the only thing I would also point out. If anybody's interested in FujiNet, I would highly recommend to go to the website, fujinet.online. There are links not only to be able to get new devices, but there are links to all of our various repositories. There's the firmware repository, which is the main firmware for the device, the hardware repository, which includes schematics, Gerbers, bombs, everything you need to build the devices yourself, which is important because we don't build them ourselves. We work with vendors in each community to try and make them available to interested people. But there's also plenty of example source code for all these different machines. And there's links to download the update software, the file servers and stuff that you need, pretty much everything that you need from a central point if you want to know more about this particular device.
Okay, I'll be sure to place that URL in the show notes.
Thank you.
Great. Well, thank you very much for your time, Tom.
You're welcome, sir.
Thank you, everyone, for listening. Let's do this again soon. Take care.